Hello, chemistry. Mr. Decker here. I'm here to help you today to fill out your evidence sheet for your performance assessment for quarter 2. On your performance assessment, you're going to be asked to fill out evidence about 2 different elements. I'm only going to do it for one element today, but the process applies for both. The element I'm going to do today is boron. You're likely going to have a different element. In fact, I know you will. And the good news is that everything that we need to find today, we can easily find in our periodic table. All right. So if you open up to the back of your notebook, you are already familiar with this. The periodic table has all of the information that we're going to need. All right. So we're going to start by just finding our element. Boron is right here. Okay. It's element number 5. And I want to start by writing the atomic number and the atomic mass. All right, so the atomic number for boron is 5, and the mass number is 10.811. Next, we want to figure out the number of particles in our element. All right, so boron is atomic number 5, and that number tells us the number of protons and electrons, right? So we can say that there are 5 protons and 5 electrons. To find the neutrons, we need to use the mass and the atomic number. So what we'll do is we're going to round our mass to the closest whole number. For boron, that's 11. And you can do the mass minus the atomic number to find the number of neutrons. So if we do 11 minus 5, we get 6. So we have 6 neutrons. Now that we know the number of protons, electrons, and neutrons, we need to draw our Bohr model. All right. To draw the Bohr model, we'll start by drawing our 5 protons and 6 neutrons. All right. Remember that the protons and the neutrons go in the center. Okay. So we'll start by drawing 5 protons. Protons are circles with a plus. Okay. So I'll draw 5 of them. And now I need to draw 6 neutrons, which are circles with an N. Excellent. Next, we want to draw our 5 electrons. Okay. We start by drawing the first ring, and only 2 electrons can go on the first ring. So we're going to put our electrons on that first ring. And now we've drawn 2, but we need 3 more so that we get a total of 5. So I'll draw a second ring, and I'll put 3 more electrons on it. So this gives me a total of 5 electrons. Now that we have our Bohr model drawn, we can figure out the number of core electrons. We're going to skip electron configuration. You don't need to do it for your PA. To find core electrons, we just count the electrons not on the outer ring. So for boron, we only have 2 core electrons, the ones on the inner ring. So we can say 2 core electrons. Using the number of core electrons and the number of protons, we can find the effective nuclear charge. We can find this by just doing protons, in this case 5, minus core electrons, which is 2. So we have an effective nuclear charge of 3. If you had a third ring on your element, then you would need to add up all of the electrons on the first and the second ring. Remember, effective nuclear charge tells you how strongly the protons in here pull on these outer electrons. So if there's a big effective nuclear charge, that means that these electrons experience a lot of attraction. They're going to be pulled really close towards the nucleus.